from the vertical. Okay, a pole tilts towards the sun at an angle, 8-degree angle from the vertical, and it casts a 22-foot shadow. So let's draw what we've got so far. So we got the sun up here. Okay, I can draw a sun. Yay, pretty sunshine. Wish we had some sunshine, right? Okay, so the pole is tilting towards the sun. So we've got vertical right here, but the pole is more towards the sun than it is from vertical. Now that's way more than 8 degrees, but I got to exaggerate it a little bit. Okay, so this is 8 degrees from vertical. Vertical makes a right angle. It cast a 22-foot shadow. So the shadow is here on the ground. The angle of elevation from the tip of the shadow, that would be down here, to the top of the pole, angle of elevation is what you look up from the horizontal, is 43 degrees. Okay, the question is, how tall is the pole? We're looking for the height of the pole right here. All right, so this is not a right triangle problem because our triangle is not a right triangle. Okay, I know I kind of have a right angle in there, but it's to illustrate the fact that this angle right here is not 8 degrees. What should that angle right there be? 98 degrees. Not the boy bands, just the angle. Okay, so let's see here. H is across from the 43 degrees, so that's good. Sine of 43 degrees. Oh, let me point out something. We can flip this over, okay? The side can be on top of the trig, okay? The side can be on top of the trig as long as you put the other side on top of the other trig, okay? It's just flipping over both ratios. I want to point that out because sometimes you might run into a problem that has it set up the opposite way. All right, so let's see here. The other length that we have is the 22, okay? What angle is across from the 22? Is it the 98 degrees? Okay. Y'all are saying 39. 39, where did that come from? 180 minus the 98 minus the 43. Okay, it is across from the 39 degrees right here. All right, so cross multiply and divide. 22 sine of 43 degrees divided by the sine of 39 degrees is equal to our height. Type that in, and we get approximately 23.842 feet is approximately our height. Okay. We're getting ready to do an example like that. Okay. All right. So, fun fact, in the 1850s, surveyors used the law of sines to calculate the height of Mount Everest. Okay. They actually used the law of sines to calculate the height of Mount Everest. And in the 1850s, before the invention of graphing calculators and all that stuff that makes y'all's life so much easier, their calculation was within 30 feet of the currently accepted value. So, fun fact there. How will I ever use this? Well, somebody uses it. Okay, so y'all do a problem, okay, like the one that I just did.